Hello, welcome to my YouTube channel. In this video, I will implement the LSTM neural network on a time series in a very simple way. I know sometimes it can be overwhelming to grasp all the moving parts of a deep learning architecture, in this case the LSTM network, but I will implement it in the best possible way so that you can breeze it through in the future. Let's get started. But before we delve deeper into the implementation, I assume you have a basic knowledge of Python and you are familiar with the term time series. Just a quick walkthrough. A time series is a type of dataset in which one or more variables were recorded with respect to time. In this video, I will make the LSTM model to train on univariate time series data, which is converted to supervised format before the training. Also, I will use the model to forecast one or more than one time steps into the future. Okay, with all that said, let's dive deeper into it. As usual, I'm importing the related libraries like NumPy and the sequential class of TensorFlow's Keras module and the LSTM and dense layers. As we know, we cannot input the time series directly into the neural network because it is not in the form of supervised data, which is comprised of feature and target matrices. So first, we have to convert our time series into the supervised data format. The function I created here does the job. Let's crack this up. Here I create a function to supervised, which will take 3 arguments. The first will be the data itself, second is the number of the input time step, and third is the number of output time steps, which is set to default equal to 1. Then I create 2 empty lists which will hold the feature and target matrices. Then I start a for loop which start from the number of input time steps all the way up to the length of the data. Here is the if condition. It ensures that the maximum reach of the for loop should not exceed the length of the data. Now pay attention and see what is going to append into the list X and Y. So look at this slice of the data and assume that I give the number of input time step equal to 3 and number of output step equal to 1. Then the first value of the loop I variable will be 3 itself. Putting the 3 here, then the value becomes this 3 minus 3 up to 3. As you know, the right hand side of the column, the value is exclusive. That means the 3 value itself will not be considered. It will be considered a 1 value less, that is 2. Then it evaluates up to from 0 to 2 index. Then see the index from 0 to 2. This is index 0, 1, 2. This slice will be appended into the X. Now see the Y. Again, I will be 3 in the first iteration and in out will be 1. So putting the values, it becomes like this: 3 to 3 plus 1, that is 4. But 4 is exclusive, which means it will go up to 3. Then it becomes from 3 to 3 and it evaluates up to the index 3 itself, which is 0, 1, 2, 3, that is 40. So this is the first iteration. Then the loop will go into second one. Now the I will be 4 and putting the 4 here and the number of input step, it will become like this: 4 minus 3 all the way up to 4, which is exclusive. Then it will be considered up to 3. 4 minus 3, that is 1. Then 1 to 3, and see this is index 1, 0, 1, 2, 1, 2, 3. Then this slice of the data time series will go to X. And now see the Y. Here I is equal to 3 and I plus n out will be 4. Here I is 4 and n out step is 1. Then it becomes from 4 to 4 plus 1, that which is this. Then it becomes 5, 4 to 5, but 5 is exclusive. Then 4 to 4, then the value at index 4 will be appended into Y. So 0, 1, 2, 3, 4, then 50. So in this manner, the values will be appended into x and y respectively. See, I iterate over here. First, at the first iteration, 10, 20, 30 will go to x and 40 will go to y. Then in the next iteration, 20, 30, 40 will go to x and 50 will go to y. Again in similar way, 30, 40, 50 will go to x and 60 will go to y. And the data will become like this. So this is the supervised data format in which these three columns represent the variable or the feature, that is feature matrix, and this column is the target variable, which is y. So our time series data has been converted into the supervised data format. See, here the number of output time steps by default I set to 1, but if I overwrite it with any other value like 2, then the feature and the target matrices will change. Then according to the new data, that which is 3, same, the number of input time step and the number of output time step will be 2. Then this matrix will contain the 3 columns and the y matrix will contain the 2 columns. That is, the output time step will be 2, which I will demonstrate later. Okay, now approaching the next section. See, up to this point we have our data into a 2D structure, but whenever we work with the LSTM network, always remember that it expects the data to be in a 3-dimensional structure or in the shape of instances, time steps and features. Here, instances simply is the number of samples in the 2D dataset. Time step is the number of columns in the 2D dataset, and features is the number of variables that were chosen to be used in the forecasting. Here it is 1, that is, we have 1 variable in the time series data. So the reshape function below does the same job. It takes the data argument and the number of features by default equal to 1, and it returns the 3D shape data by reshaping its dimensions. Now we have reached a milestone in the implementation at the data processing part. Now we have reached a milestone in the implementation in all the data process. Now we have reached a milestone in the implementation. All the data pre-processing part is over. Now all remain is to use these functions, build the model, train it, and making the predictions using the trained model. Alright then, now it's time to create a function that will build the model and return it. It will take 3 positional arguments. First is the data, of course, second is the number of input time steps, and third is the number of output time steps. Now calling the function toSupervised by giving the appropriate arguments, then reshape the feature matrix by calling the reshape function. Then by using the Keras sequential API, let's add the first hidden layer of the LSTM cells with 100 units. See, there is a general confusion among the beginners that whenever they see the first layer in the sequential API or the functional API, they consider it to be the input layer, but that's not true. It is the first hidden layer and it is mandatory to specify the input shape. Here it takes the number of time steps and the number of features. It do not take the number of samples of the data. Then again, a fully connected dense layer, it will output the result according to the number of output time step. If number of output time step is 1, then a single value will be predicted, and if the number of output time step is greater than 1, then it will output accordingly. Then compile the model using the efficient optimizer ADAM and loss equal to mean squared error. Then fit the model on x and y, which are coming from here, by calling the toSupervised function for a 200 number of epochs, and verbose equal to 2. Verbose is related to the displaying of training information. It has nothing to do with training or learning of the model itself. And then at the end, return the model. Okay, let's give our model the data, the number of input time steps and the number of output time step. Then call the function and store it into a model variable. Now sit back and relax. As soon as the model is done training, we can make it forecast for the future values, which we are going to do in the next section. Here you can see that the loss is gradually decreasing, and all the way up to the end it becomes 0.4739, and at the beginning it was around 4915. So this is a considerable success, and now we can say our model has done training and it is ready to predict for the future values. Alright, an important point to note. Remember, previously we converted the 2D data into the 3D structure, so we have to do the same with the data which we will use to predict the future values, and simply it's a matter of calling the reshape function on the xtest numpy array, then calling the predict method of the model on the xtest and saving the result into a variable called ypred, and now display the ypred. Then I am running the cell now and see what model has to predict. So it predicted 102, which is closer to 100. That would be the right answer. In the data 70, 80, 90, then what should come next? The 100, and it predicted the closest value to 100. Remember, yours and mine data may differ slightly because of the stochastic element used in the neural networks. I hope I managed to make you understand that how to use the LSTM networks in a simple way. If you want me to make more concept easier for you, then hit like and subscribe. Thank you very much.